Hi, welcome. This is a video about the discriminant, and this is the advanced video. And so what we're going to do is describe what the graph would look like, the direction of opening, and what do we know about the intercepts. Just a quick review here. The discriminant comes from the quadratic formula, and this is the quadratic formula. I've got a song to help you remember it. It's x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And that is the quadratic formula. But this part right here in blue, b squared minus 4ac, that is the discriminant. And it doesn't have the square root. It's just that part inside, b squared minus 4ac. So it doesn't give us the solutions, but it tells us about what they'll be like and how many we'll have of the different kinds. So this is what we have. If we have that b squared minus 4ac is greater than 0, which is another way of saying if it's positive, then you're going to have a situation like this where it touches the x-axis in two different places, or it could be downward facing, touches the x-axis in two places, and so this would be two real solutions. We might also say two real roots, or two x intercepts, or what's the other thing? Oh, zeros. We'd have two zeros, and those are the x values where y is 0. And if b squared minus 4ac equals 0, then we'd have a situation like this where it comes down from on top of the x-axis, comes down, touches the x-axis in just one spot, and then goes back up. Or it goes from the bottom, comes up, touches the x-axis in just one spot, and then goes back down without crossing the x-axis. But it does touch it. It makes contact. And this is one real solution, or one real root, or one real 0, or one real one x intercept. And then we have the scenario where your discriminant b squared minus 4ac is less than 0, which is a way of saying it's negative. When you evaluate that, if it's negative, this is what it's going to look like. Your graph, your parabola, if it's above the x-axis, it's upward facing, and it doesn't touch the x-axis at all. There's a space there, and so or it could be down below and it comes up and does not touch the x-axis. And so these scenarios are when we would have 0 real solutions, or 0 real roots, or 0 x-intercepts. It doesn't intercept the x-axis at all. But that doesn't mean we don't have solutions. We just have 2, but they would be non-real solutions, or we could also say two imaginary solutions. And so let's take a look at the examples that they gave us. In here, they gave us this f of x equals minus 4x squared plus 8x plus 3. I skipped one. 5x squared plus 10x plus 5. And so I look at that and I say, okay, well, A is 5, B is 10, and C is 5. Remember the standard forms: ax squared plus bx plus c. And so once I know what A, B, and C are, I can plug it into my discriminant and figure out B is 10, so that's 10 squared minus 4 times A times C, and A is 5, and C is also 5. And so I've got 10 squared, that'd be 100, minus 4 times 5 is 20, and 20 times 5 would be 100. So I've got 100 minus 100. The value of my discriminant is equal to 0. So I'm going to think, well, what was that again? Let me see. When your discriminant is equal to 0, then it has one solution. So it's going to have one x-intercept. And then I say, well, wait. What else do I know? Well, A is 5. And since that's positive, we can say this opens up. And if it opens up, now I don't know where the x-intercept is, but it could look something like this, or it could be over here, or it could be right here. But it's going to be something like this. It's going to be it touches the x-axis once, and it's upward facing. So that's why this says here it faces up, touches the x-axis once. All right, we look at this next one. It's 4x negative 4x squared plus 8x plus 3. And I've copied it over here. So A is negative 4, B is 8, and C is 3. So I can plug those values into my discriminant. B squared, that's 8 squared minus 4 times, come on, pen. There we go. Minus 4 times A times C. And A is negative 4. And C is 3. It is a good idea when you're making substitutions to put those values inside parentheses. 8 squared is 64. And then a negative times a negative is positive. So that's 4 times 4 is 16. And 16 times 3 would be 48. So that's plus 48. And if I add 64 plus 48, 72. I think that's 112. Yeah, 112. Okay, so what do I know? Well, I know 112 is positive. And so I go over here and I say, what happens? Oh, well, when my discriminant is positive, it's going to look like this. Either it's upward facing or downward facing, and it's going to cross at 2 places. So go back here, and I ask myself, what else do I know? It's going to have 2 solutions, but also my A value is negative 4. And since it's negative, that tells me, hey, this is going to open down. And so I know that it's going to look something like this. It's going to have 2 solutions because it's positive, and it's going to open down. And it's going to open down because A is negative 4. Okay, and then finally over here, and notice on this one, there's nothing in front of x squared. Remember that if there's no number in front of that variable, there's always a 1 there. And so A equals 1. B doesn't have a number. Again, we can put a 1, so B is 1. And C, well, C is also 1, so I put 1. Now, I've got the values 1, 1, and 1 here. I can plug those in over here into my discriminant. B is 1, so that's 1 squared, minus 4 times A times C. And A is 1 and C is 1. Now I just evaluate this. 1 squared is 1. Minus 4 times 1 is still minus 4, and the other 1 multiplied is also minus 4. So it's just minus 4, and 1 minus 4 is negative 3. So that negative 3, the fact that it's negative, we go over here, once again, review. We look, if my discriminant is negative, that means that it doesn't touch the x-axis, that I would have 2 imaginary solutions or 2 non-real solutions. Because remember, hey, if my discriminant is negative, we go back over here to think, what is the discriminant again? It's that part that goes under the square root. And if you have a square root of a negative number, like say if I had the square root, let's say of negative 1, let's say. The square root of negative 1 is the imaginary unit I, and that's why we would have imaginary roots if your discriminant is negative. So in this example, we can say, again, because a is equal to 1, and that is positive, we can say that this opens up, because when a is positive, it opens up. And so we don't know exactly where it's going to happen, because that's not information that we get from the discriminant. We only just know the number and type of solutions. It does not give us the solutions. -3 is not a solution. It just tells us, hey, this thing opens up and it doesn't touch the x-axis. So we'll have 0 real roots, 0 x-intercepts. All right. Hey, that's it. You've got this. Practice, practice, practice.